Hi everyone, welcome to our video on increasing and decreasing functions with the use of the derivative. So let's recall that increasing means that the function is going up from left to right. Okay, so and this is how it's kind of be written in math as well, but the main way I think of it is it goes up from left to right. And we would say that the graph has a positive slope at that moment when it's going up from left to right. Decreasing means the function is going down from left to right. So again, we always look at them from left to right, just like reading a book. From left to right, we view it. So if it's going down from left to right, we would say that it has that it is decreasing, and then that it's would have a negative slope. Okay, so let's look at this problem here where it says the graph of f of x is given below. Let's find the following: the intervals where f of x is increasing. So let's do that in blue where it's increasing. And so that means, so notice it has an endpoint here. That's okay, but I'm going to bold it. This is where I'm drawing left to right upward. So that means this is where it's increasing. And I'm just bolding it in the blue. So this is where it's increasing. And then, well, after this point, I would have to draw downwards. That means it would be decreasing. So that's not our part yet. But then after that, it goes from here to here is increasing as well. Now, increasing is only concerned about where it starts for the x and where it ends. So this graph, it increases from -5 to -2. And then there's another interval of increase, so we'll use our union symbol from 2 to 3. Okay, so let's add that. So increasing, decreasing intervals, whichever one, intervals are x values. Okay, so be careful. Don't accidentally write the y value on these. Okay, because the increasing is telling us about the y. So if it's increasing, that means y is getting bigger. So it's saying y is getting bigger on this interval and also on this interval. Okay, so those are the x values. Another thing about these increasing, decreasing intervals are x values. They are also always used with parentheses. So always use parentheses only. Always use parentheses. Okay, so even though you might say, hey, isn't that a solid dot? Shouldn't I use a bracket? Well, no, not on increasing, decreasing, because we would say at this point, before I start to draw, so this is my starting point, so that means my pencil hasn't started moving yet. So that means it's not moving up or down at all yet. So where it starts, like just kind of like the beginning of a race. So the person isn't running until the start of the race. So when we start to draw is when it starts to go increasing. Okay, so that's why we always use parentheses no matter what. Okay, and then it says the intervals where f of x is decreasing. Well, let's use red here. Right here in the red is where it's decreasing. So that's where I would draw it down from left to right. And again, make sure it's the x values, so -2, 2. So where it started to decrease to where it ended. And you can even highlight them or underline it, whatever it takes to make sure that we know it's just the x's that are important to us. Okay, so this is the interval where f of x is decreasing. And now let's go back to this real quick. I'm going to use some green. So notice if you were to plot any points on this interval, anywhere at all, and if we were to draw the tangent line, it would have a slope that's going upward. Okay, so we would see that our mtan is positive here. And if our mtan is positive here, that also means that our derivative is positive there. Okay, so where f of x increases means that our derivative is greater than 0. And we will start to get that bullet right here. So suppose that f is continuous, and it goes both ways. If f prime of x is greater than 0, then f is increasing. So here we've got f is increasing. We see that the derivative would be greater than 0. Okay, so it goes back and forth. Okay, similar with the red. If I were to choose any point on this red line and draw a tangent, it would be going down from left to right. So that's our second bullet there. If f prime of x is less than 0, then f is decreasing. So in this red interval, our f prime of x is less than 0. Or you could also say f prime of x is negative. Okay, so that's the other way to state those things there. So if f prime of x is greater than 0, that does mean f prime of x is positive. And then if f prime of x is less than 0, that means that, let's just put it right here too, f prime of x is negative. Okay, so that's the other way to say it. Okay, and then back to this blue, even if wherever I choose a point, it would have a positive slope. Okay, so that's going to be our importance connector with the derivative. Now let's get one other bullet here. So something I haven't drawn yet. Now it's getting a little messy, but I'm going to use purple. So if f prime of x equals 0, then f is constant. So that, let me mark it as like number 1. So if you have a graph like this, so that's just the line. So say this is y equals 3. Well, the slope of that is always 0. So that shows the derivative being 0 is the slope. And then this also shows the line is constant. It's a horizontal line. So that's one way that we might need to interpret it. The other way is right here, number 2. If f prime of x equals 0, then f has a turning point. So on this problem up above, we have 2 turning points. So where it goes from blue to red, or where it goes from red to blue. So where it goes from increasing to decreasing, or from decreasing to increasing. And what happens there is, well, I don't want to make it too messy, but looking at our slope, so anything in the blue we would say has a positive slope, and it's all nice and smooth. And then when it gets to the red, it has a negative slope. Well, to go from positive to negative, I need 0. So that means at this peak, at that peak right there, my slope is 0. Okay, so and this would be f prime of negative 2, because that's the x coordinate. So f prime of negative 2 is 0, because I would have a horizontal tangent. Okay, and then similar with this one, at 2, I'm going to draw that a little extended. That purple tells us, well, f prime of 2 would have been 0, because at the turning point, again, I know if I have a negative slope turning into a positive slope, if everything's smooth also, so it changes if it is not smooth, or if it's like a sharp corner, or if it's not continuous. We have different scenarios, but this is a nice smooth curve, so that means at the turning point, we have a derivative that would be set equal to 0. Okay, and then one other thing with it, so this is part of number 2 really, just kind of getting it on the graph. The x values at the turning points are called critical numbers, which could also be where the function is undefined, so we do have to be careful of that. So turning points, critical numbers. Also, if it's undefined, we would have those as well, so we'll see that eventually. Okay, so that's all of our information with graphs. So notice this derivative is connected to f based on the sign of the derivative. Okay, so let's see one other example here. Now, with this one, it says assume the following graph is f prime of x. So this is the derivative, so be careful. So this is f prime of x. Okay, so this one was just f of x. So I'm going to mark it. This was f of x. Okay, so we're going to view them differently. Okay, so on number 1, it's asking what are the critical numbers? Okay, so that's telling you find where your derivative is equal to 0. So if the derivative is the graph that's given, so we've got the derivative is graphed, that means we need to find the x-intercepts. Okay, so what are the critical numbers? So those are our x values, that are where our x-intercepts are. I'm just going to bold them in the black here. So anything that touches the x-axis. So at x equals -3, -1, 2, and 4. There they are. So those are the critical numbers. Okay, again, notice the difference. So if this was our derivative that was graphed, so I wanted those x-intercepts. On this, if they ask what are the critical numbers, I'm going to put it right here. If they said, hey, what are the critical numbers? Again, that's where the derivative would have been equal to 0. So that's where we have the turning points, because this is the f of x. So this time I do not want the x-intercepts. The critical numbers for this problem would be that x equals -2 and the positive 2. So where the x-coordinate has the turning point. Okay, so we have to be careful based on what graph they give us. Okay, and then they ask, on what intervals is f of x increasing? Okay, so let me underline that in blue. So f of x increasing, well, again, this is the graph of the derivative. So what we really need to see is where f prime of x is greater than 0, or where it's positive, or one other way to think of it is where f prime of x is above the x-axis. So that's the other way to interpret it. Okay, and so where it's above the x-axis is here. And again, it's our x-coordinates that are important, so it will be from -3 to -1 with parentheses. And then anywhere else it's above the x-axis looks like it's from 4. And we'll assume it keeps going up forever. So there's no solid dot or anything. So we'll assume it keeps going up forever. So from 4 to infinity. So, and again, it's the x-coordinates that are important. Okay, so that's the difference here. So notice I'm not concerned about drawing up from left to right because it's the derivative graph. So I'm using this rule here. The derivative is greater than 0. Tells us that f is increasing. Okay, and then one other where we've got on what intervals is f of x decreasing. So that means if I have the derivative, that means I'm looking for where the derivative is less than 0. Or again, this could be written as where f prime of x is below the x-axis. Okay, and so where it's below the x-axis, I can see it's, well, again, I'm assuming it's going down there. So below the x-axis, looks like it starts at -infinity and goes to -3. And then from -1 to 2, and I do want to put a break here. So once it touches the x-axis, that means the derivative is 0. So that means it wouldn't be, so that would mean this inequality wouldn't be true anymore. So that's why I don't want to just say from -1 to +4. So at this moment, it's not less than 0, but pretty much immediately afterwards it is. So we just break up that interval and say from 2 to 4 for our final answer. Okay, so this just shows if we have a derivative, we can still know information about the original f. It's just we have to look at it in a different view. Okay, so that's it for now. So with our graphs, again, f of x versus f prime of x, we're looking at them 2 different ways. Okay, so, but for now, that's it. So if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you next time.